Hello. In this video, I will go over the various plot and curve types in pMRI. These include parametric curves, histograms, distance projections, and the signal intensity calculator page. Let's get started. Plotting becomes available after a region of interest is defined. I can click on the Page Navigation button, select Curves page from the Views menu, or press Ctrl 4 on the keyboard to access the main plot page. The three plotting modes are parametric curve, histogram, and distance projection. Let's start with the parametric curve mode by clicking the parametric curve toggle button. The various options will change depending on the type of data I have loaded. Here I have a T2 star liver iron study, so my curve is a signal intensity versus echo time decay curve, and my curve types are signal intensity, log model fit, mono-exponential model fit, bi-exponential model fit, and LIC history. If I had a different data type loaded, such as an MRU, my curve types would also be different. The user manual has every type of curve explained in the appropriate data type section. For example, to look up the T2 star LIC curves, I can open the user manual by clicking Help, User Manual, finding the T2 star LIC section in the table of contents, and clicking on Parametric Curves. I can press the Standard Deviation button to toggle visualization of one standard deviation interval. I can limit the visible plot range by adjusting the plot range slider. I can toggle different ROI curve visibilities using the buttons on the right. When the Weights button is visible, I can toggle Weighted Fitting by clicking on it. When checked, I can right-click on it to adjust the weights. This is how I can enable or disable problematic data points when an appropriate model is selected. For example, I can do a pseudo-truncation model for this case by selecting the log model and disabling all echo times after the initial 3. Clicking the Legend button will toggle the legend on and off. Right-clicking the Legend button lets me change the legend names. Let's export what we have into Excel. I press Ctrl-C on the keyboard to copy all data to the clipboard, which I can then paste into Excel. I can also see the raw plot data in pMRI by going to the Results page and clicking Plot Data. This is also where I can see the model fit parameters by clicking the Parameters button. Let's go back to the Plots page and move on to histograms by clicking the Histogram toggle button. I can change the minimum and maximum of the histogram by adjusting the values in the min and max text boxes. The N bins text box changes the number of bins. The next two controls toggle data annotations and Gaussian fitting. If my data type is dynamic, I can scroll with the mouse wheel or adjust the time slider to change the histogram in real time. For this case, I can quickly scroll through different signal intensity histograms at various echo times. I can select the type of histogram I wish to view from the drop list. Some histograms are not available until the appropriate map type is generated. For example, if I select LIC, the histogram is empty because I have not yet generated an LIC map. To remedy this, I go back to the Analysis page, right-click on the image, and select LIC. Now, when I go back to the Plots page, the LIC histogram, as well as log and mono-exponential model histograms, are now available. Anytime I adjust plot fit weights, as I showed earlier, I will need to repeat this step because the model fit has changed. The various maps and histograms for different data types are described in the user manual. We can export tabulated histogram data into Excel by pressing Ctrl-C on the keyboard to copy and then pasting it into Excel. The raw plot data and first-order features are also available in pMRI on the Results page. The histogram section of the Curves page in the user manual describes these in more detail. Let's move on to distance projection plots. What are they exactly? Let's look at a diagram. Here we have a simple ROI. Next, I define a point of origin in the center. Next, we start to slice up the ROI into concentric regions relative to the center. In this example, we can see that we split the ROI into 5 evenly spaced regions, or as evenly spaced as my circle drawing skills in PowerPoint permit. This means that instead of getting one average value for the entire ROI, we now have 5 distinct values, each belonging to one of these areas. The yellow circle is the average value from the area closest to the center of the ROI, moving all the way to the blue area, which contains the average value from the area closest to the outer edge of the ROI. To calculate these values, we sample the ROI with projected rays in every direction. The end result produces a curve. The x-axis is the distance from the center of the ROI, or these multicolored concentric areas, and the y-axis is the average parameter value inside these areas. For example, this could be an ROI of a T1 map. The first point would be the average T1 value towards the center of the ROI, and the final point would be the average T1 value along the outer edge of the ROI. Now that we saw this concept, let's see how we can do this in pMRI. Don't worry, it only requires one extra push of a button. I have a DWI kidney dataset loaded to demonstrate. ROI1 is the parenchyma. If we go to the curves page, we will get an average signal intensity versus b-value decay curve, and the corresponding average ADC value for the entire ROI. Let's go back to the analysis page by pressing Ctrl 3 and start the distance projection process. All we need to do is hold the A key on the keyboard and click in the center of the ROI. The cursor turns into a crosshair, and we can left-click to add or right-click to erase while holding A. The point of origin is set for this slice. Let's quickly do this for several others. Let's go back to the curves page and click the distance projection toggle button. Here I have a curve of signal intensity versus distance from the ROI center on this slice. I can change the slice by scrolling with the mouse wheel, or the b-value by holding Ctrl and scrolling with the mouse wheel. Instead of looking at one slice, let's look at an average of all slices. Let's switch from signal intensity to ADC. There's a sudden jump towards the outer edge of the ROI. Let's make a better projection by doing it in 3 dimensions instead of taking a 2D average. I go back to the analysis page and place a 3D point of origin in the center of the kidney. This is done by holding Ctrl and A on the keyboard, and then left-clicking. This point of origin is different from the ones that we placed earlier because it projects outwards in all 3 planes instead of 2. Now I can view a 3D ADC distance projection. I can also see a rise in the perfusion ratio towards the edges. This could be due to higher blood flow in the outer cortex of the kidney, but before jumping to any conclusions, let's take a look at some standard deviations. I can see that there's a lot of variability in the perfusion ratio throughout the entire length of the ROI. If I go back to the ADC projection, the standard deviation stays reasonably consistent in the center and increases drastically towards the outer edges. Like with the other curves, we can press Ctrl-C on the keyboard to copy the raw plot data and then paste it into Excel. The last feature that I want to cover in this video is the signal intensity calculator in pMRI. A special thanks goes out to Dr. Dillman from Cincinnati Children's Hospital for suggesting this type of functionality. Select SI Calculator from the Views menu or press Ctrl-7 on the keyboard to open the signal intensity calculator. The plot data table allows me to manually type or paste external data and do some analysis. As an example, let's paste the signal intensity versus b-value curve of the kidney we just looked at. I go back to the curves page, select Parametric Curve mode, and press Ctrl-C to copy. I navigate back to the signal intensity calculator page and click the paste button. I could have also copied tabulated data from Excel or typed it in myself, like so. This was a DWI case, so I want to select ADC from the drop list. The fit parameter table has all values filled in. For example, I can see that the slow ADC component of the bi-exponential model is about 2600. Section 6.8 of the user manual has all models and parameters listed. The curve fit buttons on the bottom provide a visual overlay of the model fit. I can enable or disable individual points, just like I did with weighted fitting earlier in the video. I can also edit any value in the plot data table by double-clicking on it. I hope you found this video helpful, and thank you for watching.